Hey everyone, welcome back. This is Luis again on the video series that I've been doing here on how I built a LLM-powered system that runs my publishing content. This is video number 9, and in this one, we're going to delve into DynamoDB and the single source of truth. 3 points I want to talk on is just I'll walk you through on why I've chosen DynamoDB, what the single source of truth is with DynamoDB, and how it's set up. And we'll go into AWS to see that. So first things first, a single source of truth. Just like in a regular company, we want systems that are central. We call them systems of record, right? So that's the same approach that I've taken for this build. Yes, it's for myself, but it's still a professional build. And with that in mind, I wanted a system of record that held all the metadata and all the information that was required for me to be able to query everything that was happening and to change status that would eventually trigger EventBridge for any of that. Yes, everything just uses one table, but the strength in that is that I do have redundancy by way of backups. So it's a single source of truth, but not a single point of failure. So if there's ever anything that happens, I would be able to recover all my data and redeploy everything that I've just used. Additionally, I'll have CloudWatch and Cloud Logs to track all the activity that's happening on DynamoDB. So it'll help me better manage any failures or any inconsistencies in how it's working. So I mentioned that DynamoDB as a single source of truth, what I'm using for it to trigger EventBridge is if I, take a piece of content and I take it from ingested to ready for review, or then finally approve it after I reviewed all the content that's been generated for it. All those changes get sent to EventBridge via DynamoDB Streams, which is a natural functionality that AWS has created into DynamoDB. And that's my trigger then within EventBridge to take on those next steps. So DynamoDB Streams plays a big part or a critical part in updating my workflows. Now, DynamoDB is a NoSQL database for those of us that grew up using a lot more of the relational database system. The big difference here is the schema is very flexible in DynamoDB, which is great because it can evolve over time without having to break the system. It's very difficult to change a relational database. That's where my first instinct was to build and use, but not knowing how this is going to evolve over time, I didn't want to choose a schema that was just inflexible. So that's why I went with DynamoDB. And my entire schema, at least the initial part of it, is managed through Lambdas and my CDK. And in order to make DynamoDB queries faster, we use GSIs, which I'll get into what those are, but they're global indices that we can build with DynamoDB to be able to query data much faster, which is how Amazon, who built DynamoDB for its Amazon store, is able to generate and manipulate data so quickly. I'll more than likely never have anything substantial in as far as size to require something that robust, but it's still good to have because we like our systems to be resilient. We like them to be fast, and we don't want to be sitting around waiting for data to reload. So with that, let's jump into DynamoDB and the code and how this is all built via CDK. Okay, so here we are looking at the DynamoDB stack within my VS Code. As you can see, in order to build something like this, we'll be importing CDKs and constructs. It's how we build things within using CDK. I create a table right from here. One big takeaway when I built the table is I wanted to include this retain. And what that allows me to do is anytime I update or change anything with my CDK, I don't want CDK to delete the table that I just created. If anything is ever destroyed, or I tell, hey, destroy all these stacks, I'll still be able to retain DynamoDB and all its data. All the general global secondary indexes are built right from the CDK so that I don't have to do that on the console. You want to stay away from building anything in CDK and then going into the console and introducing drift, which is just a difference between what you've coded initially and then what's actually deployed. You'd always want to come in and update your CDK. And lastly, we have these outputs here for what it's going to be sent out of this file so it can be used somewhere else. But this is essentially the build. And when we go into the AWS console, we can see this entire construct already built out for us. Okay, so here we are in the AWS console. We can see that the table has been created just by virtue of the CDK. We do have the indices created by, I want to know, be able to query my tables by the created date, the scheduled date, and then by type of content. This way, it's just everything gets filtered fairly quickly and just makes things faster. Okay, so that's a quick walkthrough on DynamoDB and the single source of truth of where it lies in my whole architecture. In our next video, we're going to talk on the publishing state machine. So thank you so much for following along, and I'll see you at that next video.